Hey everyone, this is Jake here at Whatever. We literally talk about whatever. And today I'm just going to be adding to the more you know because, like I said in the first one, astronomy is like one of my biggest things, and I always keep up with the latest and greatest if I possibly can, if I can find some interesting stuff. And I think this is going to be some interesting stuff. Now, in order to kind of understand this subject, it's not like doom and gloom stuff. When you think about stuff at the in the cosmic calendar, so to speak. So, these are going to be numbers that are just going to be in the millions to billions of years into the future. But I still think it's interesting stuff, and I think what NASA and what all these astronomers and astrophysicists and everybody really put a lot of work into this stuff to try and calculate a lot of the, when stuff's going to happen, or possible outcomes for asteroids, comets, collisions, and all that other stuff. I think it's really interesting stuff, and like the playlist says, the more you know. I mean, I don't hear anybody ever talking about astronomy or anything that's going on in space in my personal circle. So, just for us, just to have some of this knowledge. All right. So, without further ado, let's just get right into it.
Can we withstand what is coming? Even while everything may seem serene when we glance up at the night sky, appearances can be deceiving. Our galaxy, the Milky Way, is speeding through the universe at an astounding 1.3 million miles per hour, even though we may not feel it. Additionally, it is heading straight for its neighbor, the Andromeda galaxy. The distance between these spiral galaxies, 2.5 million light years, won't matter soon. We are about to see the biggest galaxy collision. The Andromeda and Milky Way galaxies are about to collide. How well equipped are we for what might be our demise? Will Jupiter once more protect us? Or will it actually be a threat? In this video, we're going to find out if we can survive the largest collision our galaxy has ever seen in history. The Milky Way is far smaller than the Andromeda galaxy, which is speeding towards us at 68 miles per second. Even if that might seem quick, it will still take 4 billion years for these galaxies to collide.
And that's what I'm talking about. I haven't seen this video, but I have read a few articles about when they're supposed to collide. So, I mean, 4 billion years is a long time. We're probably going to be long gone before then, but it's just interesting to know. And to just kind of do the research on like when galaxies collide and just the after effect and aftermath and how they merge and stuff. It's pretty interesting stuff.
Because of their distance, they will eventually merge to form a single massive spherical galaxy, which will take roughly 6 billion years. The supermassive black holes that are found at the centers of the Milky Way and Andromeda will also merge in this new galaxy, which is also referred to as Milkomeda or Milkdromeda. Although the idea of such a massive collision sounds terrifying, scientists point out that individual stars are unlikely to collide due to the distance between them. And our solar system, that should also be secure. There is a slight risk that it could be entirely rejected from Milkomeda, but researchers predict that it will most likely be swept to the edge of the new galaxy. In either case, it's doubtful that humans will be alive to witness this breathtaking light display, since by this time the sun will have heated up to the point where it will have destroyed life as we know it on Earth. The Andromeda Milky Way collision is amazing because we have known about it for hundreds of years. Astronomer Vesto Slipher predicted that the Andromeda galaxy would collide with the Milky Way in the early 1900s. Since then, a large number of scientists have developed simulations to determine if these galaxies will collide or simply avoid one another. Hubble telescope data from 2012 proved there would undoubtedly be a collision. It is critical to keep in mind that these kinds of encounters are common and expected. In fact, a major collision involving the Milky Way occurred around 10 billion years ago, and smaller galaxies are frequently absorbed by larger galaxies as they pass through their orbits. It's amazing to look at the simulations and realize that we're utilizing science to forecast the future, even though we might not be here to see the development of Milkomeda. The largest ice comet nucleus ever observed by astronomers.
I know they're trying to combine the names, but that just sounds so funny to me. Oh my God.
has been measured by NASA's Hubble Space Telescope. It is bigger than the state of Rhode Island, with an estimated diameter of about 80 miles. The nucleus is roughly 50 times bigger than the center of the majority of observed comets. It is thought to be 500 trillion times heavier than the average comet discovered far closer to the Sun in mass, or, astonishingly, 500 trillion tons. On the other hand, C2014-UN271, a massive comet, is hurtling toward Earth at a speed of 22,000 miles per hour. But don't be alarmed, it will never be any closer to the Sun than 1 billion miles away, which is a little further than Saturn's distance, and that won't happen until 2031. Comet C2002-VQ94, whose nucleus is thought to be 60 miles large, previously held the record. The Lincoln Near-Earth Asteroid Research (LINEAR) team made the discovery of it in 2002. Astronomers Pedro Bernardinelli and Gary Bernstein found comet C2014-UN271 in old photographs from the Dark Energy Survey at the Cerro Tololo Inter-American Observatory in Chile. It was accidentally discovered in November 2010, when it was a staggering 3 billion miles from the Sun, pretty close to Neptune's typical distance. Since then, ground and space-based telescopes have conducted extensive research on it. Comet 2014-UN27.
Just to touch on that real quick, you know how he said 3 billion miles away, and they just throw that number around. You know how long it would take for, how long it took for like Voyager 1 or 2 to even pass by Neptune's orbit? I don't know if it passed by Neptune itself or maybe like where the orbit would have been, but it probably took forever, even with gravity assist, which is basically the craft goes around and gets an assist from the gravitational pull of the planet, and it gets catapulted out or slingshotted. Yeah. Little FYI.
One was given the more pronounceable name Comet Bernardinelli-Bernstein by Pedro Bernardinelli and Gary Bernstein. Mantu Hui of the Macau University of Science and Technology in Taipei, Macau, who is the paper's lead author, said, "This is an astonishing object, given how active it is when it's still so distant from the Sun. We had a rough idea of the comet's size, but we required the best information to confirm it. So, on January the 8th, 2022, his team utilized Hubble to capture 5 images of the comet." How to separate the solid nucleus of this comet from the massive dusty coma that surrounded it was a measurement difficulty. The comet is now too far away from Hubble to resolve its nucleus visually. Instead, a brilliant spike of light may be seen in the Hubble data near the nucleus. The last step was to create a computer model of the surrounding coma that Hui and his team then modified to fit the Hubble photos. The coma's light was then removed to reveal the star-like nucleus. The brightness of the nucleus was compared by Hui and his team to prior radio observations made in Chile using the Atacama Large Millimeter Submillimeter Array, ALMA. The diameter and reflectivity of the nucleus are restricted by the combined data. The new Hubble observations convincingly point to a darker nucleus surface than was previously believed, yet they are close to the earlier ALMA size estimates. It's large and darker than coal, according to Dewitt. For well over 1 million years, the comet has been moving in the direction of the Sun. The Oort cloud, which is thought to be the home of billions of comets, is where it is coming from. The inner edge of the diffuse cloud is estimated to be between 2,000 and 5,000 times further away from the Earth than the Sun. Its outer border may extend at least 1/4 of the way out to the Alpha Centauri system, which contains the nearest stars to our Sun. The comets of the Oort cloud didn't originate that far from the Sun. Rather, they were flung out of the solar system billions of years ago by a gravitational pinball game between the enormous outer planets, while Jupiter and Saturn's orbits were still forming. The far comets can only return to the Sun and planets if a passing star's gravitational pull disturbs their orbits, tossing them from the tree like apples. In its 3 million year long elliptical orbit, the comet Bernardinelli-Bernstein travels as far from the Sun as approximately half a light year. Currently, the comet is plummeting roughly perpendicular to the plane of our solar system and is less than 2 billion miles from the Sun. Temperatures are just about minus 348 degrees Fahrenheit at that distance. The dusty comet is the result of carbon monoxide sublimating off the surface at such a temperature, though. The comet Bernardinelli-Bernstein offers crucial information about the Oort cloud's total mass and the size distribution of its comets. The mass of the Oort cloud has been estimated to be as much as 20 times that of the Earth. The Oort cloud, first proposed by Dutch astronomer Jan Oort in 1950, continues to be a theory, since the countless comets that make it up are too weak and far enough to be directly witnessed. Ironically, this implies that the biggest structure in the solar system is practically undetectable. According to estimates, it might take up to 30,000 years for NASA's 2 Voyager probes to traverse the Oort cloud and another 300 years to reach its inner region. Infalling comets that can be traced back to this breeding habitat provide circumstantial proof. The cloud must be spherical in shape because of the many ways they approach the Sun. These comets are long-preserved deep freeze samples of the early solar system's composition. Theoretical simulations of the genesis and evolution of the solar system support the actuality of the Oort cloud. The more observational data that can be acquired through multi-wavelength and deep sky surveys, the more astronomers will be able to comprehend the Oort cloud's function in the development of the solar system. Some have referred to this find as a mega-comet, since it may go down in history. It may be the largest comet ever discovered. Its estimated width ranges from 60 to 230 kilometers. To put the size in perspective, Long Island is 118 miles long. Halley's Comet is roughly 3.5 miles broad, and a portion of the Florida Peninsula is 160 miles across. Despite its size, this comet is not a threat to Earth's inhabitants, but there is a chance that it might put on a sky show as it makes its first voyage in millions of years to the inner solar system. If a space rocket of this scale were on a collision path with Earth and slammed into the continent, that would be a nasty day, to put it mildly. The asteroid that is supposed to have contributed to the extinction of the dinosaurs was only 7 miles wide when it struck Mexico's Yucatan Peninsula, leaving a crater that was 125 miles wide. The effects and climate changes from a space rock the size of Comet Bernardinelli-Bernstein striking land would be orders of magnitude worse. The rock may cause a tsunami if it landed in the ocean rather than on land. According to estimates from NASA, there is a 0% probability that these events will occur in 2031, when the comet will make its closest approach to the Sun. Even though Comet Bernardinelli-Bernstein is already close...
Oh, now this may be just kind of a side note, but the bigger planets, like he talked about, like Saturn and Jupiter, like he was saying earlier, they're big deterrents for a lot of like asteroids and meteors and stuff, and even comets. So before anything even like gets close to Earth, the gravitational pull is so strong for some of those planets that they really save us a lot of times. So we're in a pretty good position. I mean, that's all I'm going to say about that, you know.
To the Sun than Neptune, it won't begin its lengthy return to the outer solar system until 2031, when it will have already passed Saturn's orbit. The enormous comet will remain far from Earth, requiring a telescope to see it in the sky, according to current predictions, but it may still astound observers in 2031. When it comes to brightness, comets are renowned for being erratic. Given its size and limited information now available, this comet may wind up exceeding expectations and putting on a show for astronomers. Is it accurate to say that Jupiter may be our friendliest planet because comets would be more likely to strike us without it? The response is both yes and no. Some astronomers think that one reason Earth is able to support life is that Jupiter's gravity helps shield us from some comets. Particularly long-period comets join the solar system from its farthest regions. Most of these rapidly moving ice balls are predicted to be flung out of the solar system by Jupiter's gravity before they can approach Earth. Therefore, it is believed that long-period comets only collide with Earth for extremely long periods of millions or tens of millions of years. Long-period comets would strike our planet far more regularly if Jupiter weren't so close by. In addition, scientists have recently been able to spot evidence of comets that have collided with Jupiter. In 1994, comet Shoemaker-Levy 9 was observed. Additionally, in 2009, scientists noticed a black gash on the big planet's side that was probably produced by a comet. However, Jupiter both favors and precludes life on Earth. An asteroid belt, which is made up of thousands of tiny flying pieces of debris, exists in our solar system today because of its strong gravity, which prevents space rocks circling close to it from condensing into a planet. Asteroids are still affected by Jupiter's gravity today, but some of them are now being pushed toward the Sun and have the risk of crashing with Earth. Another intriguing tale dates back hundreds of years. A comet rarely approaches Earth within 1 astronomical unit. That is 1 Earth-Sun distance, 92 million miles, or about 150 million kilometers. However, a comet named Lexell whizzed by Earth in 1770 at a distance of just 1 million miles. 3 years earlier, the comet had streaked into view from the edge of the solar system. As it approached Jupiter, which changed its orbit, it headed directly for Earth. The comet made 2 orbits of the Sun before coming extremely close to Jupiter once more in 1779, which flung it back into space. Jupiter seems to have shot at us but missed. So, is Jupiter Earth's protector? The answer is occasionally. As a result, we must start making the necessary preparations to safeguard both our planet and ourselves from these threats. NASA has been working diligently on a number of initiatives. The Double Asteroid Redirection Test is one of them, DART. The Didymos Reconnaissance and Asteroid Camera for Optical Draco Navigation Image.
They don't want to call what's his name, Bruce Willis and Ben Affleck and all those dudes to go into space. That's a pretty bad joke, but
apparatus, according to the space agency, is located beneath the spacecraft's panels. DART is an intriguing fusion of new and ancient technologies, with some of the latter being shown off on a spacecraft for the first time. Because humans don't want to become extinct like the dinosaurs, NASA is organizing a mission to investigate ways that an asteroid could be diverted in the future. It will arrive at Dimorphos, a stadium-sized asteroid that orbits the considerably larger asteroid Didymos, after spending a year in transit. At a horrifying speed of about 4 miles per second, that's 6.5 kilometers per second, the DART spacecraft, which is the size of a car and weighs about 1/3 of a ton, will collide with the asteroid. If all goes well, Dimorphos's orbit around Didymos will be modified minute by minute over a period of about 12 hours. The impact energy of DART's collision with Dimorphos will be roughly equal to that of 3 tons of TNT detonating, sending thousands of bits of debris into space. According to SlashGear, which cited the MIT study, the outcome would be comparable to a golf cart colliding with the side of a football stadium at a speed of 15,000 miles per hour. The impact will not immediately cause Dimorphos's spin to change. Rather, this will happen gradually over a number of days. Dimorphos will first exhibit a little amount of wobbling, which will intensify when the force of the impact knocks the asteroid's spin out of equilibrium. The asteroid will continue to wobble until all of the impact energy has been converted into asteroid motion, since there is no friction between the asteroid and outer space. Dimorphos had several different ways it could spin, including around its axis, like a rotisserie. And anyone seeing Didymos from the surface would see that the formerly stationary satellite is now swaying crazily back and forth, with its former dark side suddenly revealing its face. As a practice run for preventing the destruction of the Earth by an asteroid,
don't let this video or these videos fool you when they're moving all slow like that. I mean, those things are hauling. All right, that's sending a spacecraft to crash into that. It may knock it off its orbit or something, but as far as anybody thinking it's going to go do some damage, even if you just shot like a nuclear warhead at it or something, I mean, those things are are flipping hollering.
Is fantastic. Research into a variety of extremely complex processes, from a chaotic spin state to the impact of sunlight and heat propagation, would be necessary to comprehend the outcome, though. Thanks for watching another episode.
I mean, well, there you have it. It talked about Andromeda, and then it started going into comets and stuff. But the Andromeda part, that's pretty sweet. I've read an article saying that it's already happening, like the merger's already happening, but the galaxies are so massive, and you can't even really like feel it or see it. And there's like I said earlier in the video, there's just so much space in between all the solar systems and stars and stuff that it probably isn't really going to have any sort of an effect aside from the galaxies merging. But let me know what you think. Let me know down in the comments. I mean, is this something that you enjoy, or maybe you learned something from the video? I know I did. I always enjoy these kinds of videos. But until the next update, I hope you enjoyed it, and just keep on sending it.